Let me deflate this immediately, because the mystique is doing real damage. An AI agent is a while loop. That is not a joke, and it's not a simplification. You call the model, it asks to use a tool, you run the tool, you put the result back in the context, and you call the model again. And you keep doing that until it says it is finished. That is the whole architecture. Every agent framework you have heard of is that loop with a class hierarchy around it. And once you see that, the interesting question stops being how do I build an agent, because you now know, and becomes why do so many of them fail? Because they do. Most agent demos are beautiful and most agent products are quietly disappointing, and the gap between the two is entirely predictable. It is compounding error, and we will do the arithmetic. 9 concepts. 1 running example. An agent that handles a customer refund, end to end. By the end, you will be able to build one, and, much more valuably, you will know when not to. Start with what a single model call cannot do. Refund the customer's order. To actually do that, you must look up the order, check whether it falls inside the refund window, check whether the item was returned, call the payment provider, update the database, and email the customer. 6 steps, and they are non-independent. Step 2 depends on what step 1 returned, and if the item was not returned, the whole plan changes. You cannot write this as one prompt, because the model does not have the data and cannot take the actions. And you cannot fully write it as a fixed pipeline either, because the path branches on facts you do not have until runtime. What you need is something that can look at the situation, decide what to do next, do it, look at the result, and decide again. A loop with a brain in it. That is an agent, and the definition worth holding is this. An agent is a system where the model decides the control flow. That single sentence is what separates an agent from a workflow, and it is the most important distinction in this episode. Concept 1. The loop. And there is genuinely nothing else. Here it is, completely. You have a list of messages and a list of tools with their descriptions and schemas. You call the model with both. The model returns one of 2 things, either a final answer, in which case you break out of the loop and you are done, or a request to call a tool with arguments. If it is a tool call, you execute the tool, you append the result to the messages, and you loop. That is 15 lines of code, and it is the entire pattern. LangChain, Crew AI, AutoGPT, every framework, all of them are this loop wrapped. And here is why it is worth seeing it plainly. People attribute agent failures to the framework and go looking for a better one. The framework is not where your failures come from. Look at what is actually happening. The model is making a decision at every iteration, using only what is in the context, with no memory of anything you did not put there, and it will happily loop forever if you let it. Everything that goes wrong with agents goes wrong inside that loop, and switching frameworks moves the problem without solving it. Concept 2. The arithmetic that explains every failed agent. This is the most important concept in the episode. Suppose your model gets each individual step right 95% of the time. That is a good model on a well-described tool. Now, what is the probability it gets a 5-step task completely right? 0.95 to the power of 5, which is 77%. 10 steps, 60%. 20 steps, 36%, 30 steps, 21%. Read that again. A model that is 95% reliable per step is wrong more often than right on a 30-step task, and there is no prompt that fixes it. Because nothing is broken, it is multiplication. And it gets worse than that, because errors do not just accumulate, they compound. A wrong tool call as step 3 does not merely fail, it puts wrong information into the context, and every subsequent decision is now made on a false premise. The agent confidently builds on its own mistake. So what do you actually do? Fewer steps. Every step you can remove from the loop is a multiplication you no longer pay. Higher per step reliability. Better tool descriptions and stricter schemas move at 95 to 99. And across 10 steps, that is the difference between 60% and 90%. Checkpoints. Verify at critical points instead of trusting the whole chain, and a human in the loop before anything irreversible. If you take one thing from this episode, take the multiplication. It is why the demo works and the product does not. The demo was 3 steps. Concept 3. Tools. Where your reliability actually comes from. Given that per-step reliability is being raised to a power, the highest leverage thing you own is the tools, because they are the thing that determines whether a step succeeds, and they are consistently the least thought about part. So, the description is the interface. The model has never seen your code. The name, the description, and the schema are its entire understanding, and a vague description produces a wrong call that is not a bug in your tool. Make tools coarse, not fine. Do not give the model get_user, get_orders, and get_order_items and expect it to compose them. That is 3 steps and 3 chances to fail. Give it get_customer_order_history. 1 call, 1 chance. Every tool you merge is a multiplication you delete. Make the schema strict, enums, not free text, because a model choosing from 4 options is far more reliable than one writing a string you will then parse. And return errors as instructions, not as codes. Order not found is a dead end. Order not found. Check the order ID format. It should be ORD- followed by 6 digits is a second chance. The model reads your error and tries again. So your error message is a prompt. And fewer tools. An agent with 40 tools picks the wrong one far more often than one with 8. If your agent is unreliable, fix the tools before you touch the prompt. Concept 4. Memory, which is mostly a euphemism for context management. Every loop iteration appends to the context, the tool call, the tool result, the model's reasoning. And tool results are big. A database query returns rows, an API returns JSON, a page returns text. So the context grows fast and 3 things go wrong. You run out of window and it hard fails. Cost climbs, because you are resending the entire history on every single iteration. An agent's cost is quadratic in its length, which surprises people when the bill arrives. And accuracy drops. The important instruction from step 1 is now buried under 9 tool results, and that is the lost in the middle effect biting you. So you manage it. Summarize all turns, compress the history once it passes a threshold, keeping decisions and dropping raw output. Truncate tool results at the source. Your tool should return what is useful, not everything available. And separate short-term from long-term. The loop's context is working memory, and anything that must persist across sessions goes in a database or a vector store and gets retrieved when relevant, which is RAG, doing a job inside your agent. The point to internalize is that agent memory is not a cognitive feature. It is context window plumbing, and the frameworks that sell it as intelligence are selling you a ring buffer. Concept 5. Planning, and an honest look at whether it helps. The pitch is that your agent should first write a plan, then execute it. And there are 2 schools: react, reason, and act. Interleaves, think, act, observe, think again. The model reasons before each step. In the loop, it is adaptive, it handles surprises, and it is what most agents actually do. Plan and execute writes the whole plan up front and then runs it. It is cheaper, because you reason once instead of every step, and the plan is inspectable. You can show it to a human before anything happens. But it is brittle, because the moment reality diverges from the plan is wrong and the agent is following it anyway. Now the honest bit, which the frameworks will not tell you. Planning helps most when the task genuinely has structure the model can exploit, and it helps least when the task is short. For a 3-step task, a plan is overhead and another thing that can be wrong. And a plan generated by the model is not a guarantee of anything. It is more tokens the model produced, and it can be confidently wrong in exactly the way the execution would have been. Explicit planning buys you inspectability and a place to insert a human, and those are real. It does not buy you correctness. Do not mistake a plan for a proof. Concept 6. The decision that most teams get wrong, and the one that will save you the most pain. This is the concept I would most like you to walk away with. A workflow is a system where you write the control flow, and you call the model at specific steps to do specific things. An agent is a system where the model decides the control flow, and the industry has stampeded toward agents when workflows would have been better, faster, cheaper, and dramatically more reliable. Think about our refund. Do you actually need the model to decide the order of operations? No, you know the order. Look up the order. Check the window, check the return, refund, notify. That is a fixed sequence. The parts that genuinely need judgment. Is this a valid refund reason? Is this email angry enough to escalate? Are single model calls at specific steps? Write it as a workflow with 2 model calls in it and you get something you can test, whose cost you know before it runs, that fails in ways you can debug, and that is right 99% of the time instead of 60. So when is an agent genuinely right? When the number of steps is unknown up front. When the path branches on things you cannot enumerate. When the task is genuinely open-ended. Research this topic, debug this failure. The test is, can I draw the flowchart? If you can draw it, build the flowchart. You only need an agent when the flowchart cannot be drawn, and that is far rarer than the market implies. Concept 7. Testing something non-deterministic, and almost nobody does. Your agent is non-deterministic. The same input can produce a different path, so unit tests, in the form you know, do not straightforwardly apply. And the usual response is to test it by hand, ship it, and hope. That is why so many agents are quietly bad in production, and nobody can say by how much. So build an eval set, 30 to 100 real tasks with the expected outcome. Then measure 3 things, and measure them separately. Task success. Did it achieve the goal? That is the number that matters, and it's binary, and you will not like it at first. Trajectory. Did it take a sensible path, or did it flail? Call the same tool 5 times, wander, get there by luck. A correct answer via a lunatic path is a warning, not a pass. And cost and steps, how many iterations and how many tokens, because an agent that succeeds in 40 steps and $3 is not a good agent. Then the 2 things that actually matter operationally. Add regression tests for every failure you find, because agents regress silently when you change a prompt, and log every trajectory in production, because the failure you have not imagined is the one that will happen, and without traces you will never know it did. An agent without evals is not a product. It is a demo you are charging for. Concept 8. Multi-agent systems, and a genuinely unpopular opinion. The fashionable architecture is a team of agents, a researcher, a writer, a critic, a manager, all talking to each other. It demos brilliantly, and it is largely a mistake, and I want to make the case carefully rather than just be contrarian. Remember the multiplication. If one agent has compounding error, a system of 5 agents has compounding error compounded, and now the errors travel between agents, so hallucination by the researcher becomes an input the writer trusts completely. You have added handoffs, and every handoff is a lossy compression of context. You have multiplied the cost, because 5 agents means 5 times the model calls, at least. And you have made debugging genuinely miserable, because when the output is wrong you now have to work out which agent was wrong and when. And they were talking to each other in natural language, which is the least debuggable interface ever devised. The alternative is nearly always better. One agent, good tools, and a deterministic workflow around it. What you actually wanted was structure. Do this, then that, then check. And structure is a program, not a committee. When is multi-agent genuinely right? When the subtasks are truly independent and can run in parallel. And when each agent needs a genuinely different toolset or context that would not fit together. That is a real pattern, and it is much narrower than the framework suggests. The honest heuristic: if you cannot make one agent work reliably, 5 will not save you. They will fail 5 times as expensively, and you will not be able to tell why. Concept 9. When an agent is genuinely the right call. 4 questions, and they are deliberately biased against building one, because complexity should have to earn its place. 1. Can I draw the flowchart? If yes, build the flowchart. A workflow is cheaper, faster, testable, and rate far more often. 2. How many steps? Do the multiplication before you build. If the task needs 20 steps and your per step reliability is 95%, you are shipping something that works a third of the time, and you should either shorten the task or not build it. 3. What is the cost of being wrong? An agent that drafts an email for a human to send is a fine use of an unreliable system, because the human is the check. An agent that issues refunds without review is a liability, and the fix is not a better prompt. It is a confirmation step. 4. Is the path genuinely unknowable up front? That is the only real justification for the model owning control flow, and it is rarer than people think. Now, the honest state of the field, and I would say this in an interview. Agents work today for tasks that are short, where tools are excellent, and where a human checks anything irreversible. They do not reliably work for long autonomous chains, and anyone claiming otherwise is showing you a demo, not a production system. That will change as models improve. Every point of per-step reliability lifts the whole curve, but build for the models you have, not the ones in the announcement. Let us put it back together. An agent is a while loop. Call the model, run the tool it asked for, append the result, repeat until done. That is the whole architecture, and every framework is that loop wrapped in classes. The definition that matters is that the model decides the control flow, and if you decide it, you have a workflow, and a workflow is usually better. The arithmetic explains everything. 95% per step is 36% over 20 steps, and no prompt fixes multiplication, so delete steps. Raise per-step reliability with better tools, checkpoint, and put a human before anything irreversible. Your tools are your agent. Make them coarse, strictly typed, and write errors as instructions. Memory is context window plumbing, not intelligence. Planning buys inspectability, not correctness. Multi-agent multiplies your errors and your bill and destroys your ability to debug. Build evals or you are guessing, and ask the 4 questions honestly. Can I draw the flowchart? How many steps? What does being wrong cost? Is the path truly unknowable? Most things called agents should be workflows. Next in this series, Llama and running models locally. Subscribe.